Game Theory with Engineering Applications Unit 3 for RGPV Exam 2023 notes are in comments section. Introduction to Systems. A system is a collection of interconnected elements that work together to achieve a common purpose or function. Systems can be found in various domains, including nature, engineering, social sciences, and organizational management. The study of systems focuses on understanding the relationships and interactions among the elements within a system. Elements of a system. 1. Components, elements. Components are the individual parts or elements that make up a system. Each component has a specific function or role within the system. Examples of components in different systems. In a computer system, components can include hardware, processor, memory, storage, and software, operating system, applications. In an ecological system, components can include organisms, plants, animals, and their interactions. 2. Interconnections, relationships. Interconnections refer to the relationships and interactions between the components of a system. These connections can be physical, informational, or causal, and they define how the components influence each other. Interconnections determine how the system as a whole behaves and functions. Examples of interconnections. In a transportation system, the roads, vehicles, and traffic signals are interconnected to regulate the flow of traffic. In an organizational system, departments and teams are interconnected through communication channels and workflows. 3. Boundaries. A system has boundaries that define its scope and distinguish it from the external environment. Boundaries determine which components are considered part of the system and which are external to it. Understanding the boundaries is important for studying the inputs, outputs, and interactions of the system. Boundaries can be physical, conceptual, or operational. Examples of boundaries. In an ecosystem, the boundary can be defined by geographical limits or the presence of certain species. In a software system, the boundary can be defined by the interfaces between different modules or components. 4. Inputs and outputs. Systems receive inputs from the environment, process them internally, and produce outputs. Inputs are the resources, information, or stimuli that enter the system. Outputs are the results, products, or outcomes generated by the system. Inputs and outputs are essential for the functioning and adaptation of the system. Examples of inputs and outputs. In a manufacturing system, inputs can include raw materials, energy, and labor, while outputs can be finished products. In a communication system, inputs can be messages or signals, while outputs can be received messages or transmitted signals. 5. Purpose, function. A system exists to serve a specific purpose or function. The purpose defines the goals or objectives the system aims to achieve. The components, interconnections, and boundaries of the system are designed to fulfill its purpose. Examples of purposes. In a transportation system, the purpose is to facilitate the movement of people and goods from one location to another. In an educational system, the purpose is to provide knowledge and skills to learners. 1. Framing systems. Framing systems involve defining the boundaries, perspectives, and parameters used to analyze and understand a particular system. The way a system is framed influences how it is perceived, studied, and analyzed. Different frames can highlight different aspects of a system and shape the understanding of its components, relationships, and behaviors. 2. Open systems. Open systems are characterized by an exchange of matter, energy, or information with their environment. Open systems interact and interface with the external environment, receiving inputs and producing outputs. They have permeable boundaries that allow the flow of resources, communication, and interactions. Open systems are dynamic and can adapt, evolve, or be influenced by changes in their environment. Examples of open systems. Ecosystems. Ecosystems receive energy from the sun, exchange nutrients with the soil, and interact with organisms in their environment. Organizations. Organizations interact with customers, suppliers, and stakeholders, exchanging resources, information, and products, services. 3. Closed systems. Closed systems are self-contained and do not exchange matter, energy, or information with their environment. Closed systems are isolated and operate based on internal interactions and processes. They have rigid boundaries that restrict external interactions and influences. Closed systems tend to be more stable and self-regulated. Examples of closed systems. A sealed terrarium. A sealed terrarium operates as a self-sustaining ecosystem with no exchange of matter or energy with the external environment. A watch. A mechanical watch is a closed system that operates based on internal components and does not require external inputs. Key differences between open systems and closed systems. Exchange with the environment. Open systems exchange matter, energy, or information with the environment, while closed systems do not. Permeability of boundaries. Open systems have permeable boundaries that allow interaction, while closed systems have rigid boundaries that restrict interaction. Adaptation. Open systems can adapt and evolve based on environmental changes, while closed systems are self-contained and less adaptable. Stability. Closed systems tend to be more stable, while open systems may exhibit greater variability due to external influences. Examples: ecosystems, organizations, and living organisms are examples of open systems, while sealed terrariums and mechanical watches represent closed systems. Introduction to interactivity. Interactivity refers to the ability of a system or medium to respond to user input or engagement. It involves a reciprocal relationship between the user and the system, where actions and responses occur in a continuous loop. Interactivity can enhance user engagement, immersion, and agency, making the experience more dynamic and participatory. A multivalent model of interactivity. A multivalent model of interactivity recognizes that interactivity can exist in various forms and degrees. It highlights different dimensions or levels of interactivity, ranging from low to high, based on the nature and depth of user-system interactions. 1. Information exchange level. At the information exchange level, interactivity involves basic communication and the transmission of information. Users provide input or requests, and the system responds with predetermined information or content. Examples: navigating a website and accessing information by clicking on hyperlinks. Using search engines to retrieve specific information based on user queries. 2. Reactive level. At the reactive level, interactivity involves the system responding to user actions or inputs. The system reacts to user commands, triggering pre-programmed responses. Examples: playing a video game where the character moves, jumps, or attacks in response to player button presses. Using a voice assistant like Siri or Alexa, where the system responds to voice commands with appropriate actions or information. 3. Transactional level. At the transactional level, interactivity involves a two-way exchange where both the user and the system have influence and impact. Users engage in meaningful interactions that affect the system's behavior or outcomes. Examples: participating in an online discussion forum or social media platform, where users create content, respond to others, and shape the community. Customizing settings or preferences in software applications to personalize the user experience. 4. Generative level. At the generative level, interactivity enables users to actively create or modify content, contributing to the system's evolution. Users have significant control and authorship, shaping the system's functionalities or outputs. Examples: collaborative platforms like Wikipedia, where users contribute, edit, and co-create content. Programming environments or game creation tools that allow users to design and develop their own software or games. Thanks for watching. Like, subscribe and share.